Thank you for joining this physics lesson. We're going to discuss waves 1. Figure 10 shows a displacement time graph for a certain wave motion. Displacement in centimeters in the vertical axis, and we also have displacement or distance covered by the particles, again in meters, in the horizontal direction. This is the KCSE 2018 Physics Paper 2. We are told to first of all indicate on the figure with letters A and B any 2 points that are in phase. For 2 points to be in phase, it has to be noted that they have to be at the same displacement from the mean position and going at the same direction. Therefore, points which are at the crest, like a point at this and another point at this, are in phase, because at any given time this point is moving at the same direction with this one. Another definition of 2 points which are in phase, the distance between these 2 particular points which are in phase should be a complete wavelength. Therefore, as long as between 2 points there is a complete wavelength, we can say those 2 points are in phase. There is a complete cycle. Therefore, from this point to this one at a trough, there is a complete oscillation, and hence the 2 points are in phase. When you consider this wave motion at 20, a particle moving in this direction will move until at 40, where it will be at the same position and moving in the same direction. Therefore, we can say a particle at this point and another one at this are in phase, because at that particular time, or at any particular time, they are moving in the same direction and at the same position. Therefore, we can label any of the described points. We can have A at this point, B at this point. So a point at this mark and another point at this mark are in phase. Alternatively, we can use a crest and another one, a trough and another one, or any other point, as long as the distance between them is a complete wavelength. Determine the amplitude of the wave. Determine the amplitude of the wave. It has to be noted that amplitude, abbreviated capital A, is usually the maximum displacement on either sides of the mean position. So the particles are going a maximum displacement of 10 centimeters upwards, a maximum displacement of 10 centimeters downwards. Therefore, it is 10 centimeters, and because displacement should be given in SI units, we can have this as 0.1 meters. So that is the amplitude. Determine again the wavelength of the wave. Wavelength lambda is abbreviated this. This is the distance between 2 points which are in phase now. Therefore, from 20 to 40, that is 20 centimeters. Or rather, at any other point whereby we can consider the mid here. If this is 20 and 30, then this is going to be 25. Then the point here, this is 40 and 50, this is 45. So from 25 to 45 is also another wavelength, and many other wavelengths. From 0 all the way to 20, that is a wavelength. So they are all confirming that the wavelength in this wave is 20 meters. So 20 meters will be the wavelength of this wave. The question continues to tell us, given that the frequency, let me go to the next page. Given that the frequency of the wave is 50 Hz, determine the period. Part 1, determine the period of the wave. Period is the time taken to cover a complete oscillation. Period is usually abbreviated capital T, and it's usually given by the reciprocal of the frequency. Therefore, 1 out of 50 will give us the periodic time. In this case, 1 out of 50 is equivalent to 0.02. Of course, seconds now that we are talking about time. The next thing to determine is the speed of the wave. Speed of the wave, V, is usually given by F frequency multiplied by lambda. This is going to be a frequency of 50 times a lambda of, we had determined lambda already as 20. Yeah, as 20. So this is going to give us 5 by 2, which is 10, then 2 zeros, meters per second. I think alternatively, we can have speed being given by, speed, this is alternatively, speed can be given by lambda out of periodic time, because lambda is a distance between 2 points at phase, or which are in phase, and now periodic time is the time taken to cover such a distance. So wavelength is a distance, and the period t is the time taken to cover a complete wavelength. Therefore, with a wavelength in this case of 20 and a periodic time of 0.02, we will get the same speed of 1,000 meters per second. Thank you for following. Subscribe and share.